Hello, today we're going to talk about solving radical equations. So, solving a radical equation is just like solving any other equation, except we have to use a different method to get the x all by itself. Remember, our goal for solving equations is to get x by itself on the left side and some value on the other side. So, how do we do this with radical equations? Well, the first thing is we want to note that x, the square root of x, can be written as x to the 1/2 power. And we want to eliminate this 1/2 power. Now, the way to undo this, to get rid of it, is remember if we have x to some, let's say some fractional power, 1 over a, and we raise that to some other power, b, that's going to give us x to the b over a. So our goal is for us to get x to the first power all by itself, right? And so in order to get rid of this 1/2, we're going to need to raise it to the second power. So if I take my original equation, x square root x equals 4, and I raise both sides to the second power, that's going to give me x equals 16. And that is going to be my answer. Now, usually with radical equations, we want to test our solutions to make sure that they work. So if I plug this 16 back in, I get the square root of 16 equals 4. Perfect. So this is indeed the solution. All right, next equation. So we have the square root of negative x plus 1 equals 3. So we're going to want to do the same process of, since the radical is on the left side, we have a number on the other side, we can raise both sides of the equation to the second power. So we get the square root of negative x plus 1, all of that to the second power equals 3 to the second power. So I get negative x plus 1 equals 9. Now I want to get x all by itself on the left side, so I'm going to subtract that 1 over, minus 1, and I get negative x equals 8. I have a negative x, which I don't want, so I need to get that negative onto the other side. So to do so, I'm going to divide by negative 1, and I get x equals negative 8. Now again, I want to test the solution to make sure it works. So going back to my original equation I started with, I plug in negative. Now remember, x equals negative 8, and I have a negative x in the radical. So this is going to become negative 8 plus 1. A negative of a negative gives me a positive, so I have 8 plus 1 equals square root 9, which gives me 3, which was the original value. So this is a solution. All right, next equation. We have x minus 9 plus 3 equals 5. Now, this equation is a little different because I have a radical plus some value equaling another value. What I want to do is get this 3 over to the other side first before I do my squaring property. So I need to subtract the 3 from both sides. So that I am then left with x minus 9 equals 2. Remember, I want to get the radical all by itself on one side and a number on the other side. Now I can use my squaring property to get x minus 9 equals 4. Now I can add my 9 over, add 9, and I'm left with x equals 13. Now again, we're going to want to check our solution. So we plug it in, so we get x minus 9, we get 13 minus 9 plus 3. That gives me square root 4 plus 3, which gives me 2 plus 3, which equals 5, which is what I had at the beginning. So x equaling 13 is a solution. All right, last problem I'm going to go over. Square root x minus 10 equals negative 5. First thing I'm going to do is square both sides of the equation. So I have x minus 10 squared equals negative 5 squared. So then I'm left with x minus 10 equals 25. All right, now I have x on the left side and a 10. I want to move that 10 over, so I'm going to add 10 to both sides. So I get x equals 35. All right, now again, we're going to want to check our solutions to make sure it actually works. So we plug in that 35 minus 10. That gives us square root 25, which gives us 5. But this value does not equal the negative 5. Therefore, x equaling 35 is not a solution. Why is this the case though? Because we have a logic here where everything works and we do get a value. Why does this not work when we plug it back into the original equation? Well, let's take a look back at the original equation we started with. We have the square root of x minus 10 equals negative 5. Can a square root of something ever be negative? Implying, do you know a number when times by itself, it equals a negative value? No, because remember, if I plug in a positive value, take, for instance, 5, right? 5 times 5 gives me positive 25. And negative 5 times negative 5 also gives me a positive 25. There are no values that are both positive and negative at the same time. Therefore, whenever our radical equals a negative number, whenever we have x equaling some negative value, this is not a solution. No, this is implying that we have no real solution. So the answer to a problem like this, if you ever encounter it, would be no real solution.